The insertion sort algorithm is another iterative sorting algorithm that can be used to sort elements in an array or array list. So this algorithm checks a number against the previous numbers in the array list and inserts the number at the sorted position. So let's make sense of this by going through this pseudocode. So the algorithm takes an input, being our unsorted array list, and then outputs the sorted array list. And the outer loop starts at the iteration I equals 1 and sets a variable key to be the current element in this array list. And a variable j is set to the index of the previous element in this array list. So while j is greater than or equal to 0, which is true, and the element at index j is greater than the key, which is also true, then the element at index j plus 1, which is 3, is set to the element at index j, which is 4. And then j is decremented, so now it's equal to -1. And then in the next iteration, j is not greater than or equal to 0, so this loop is terminated. And then the element at index j plus 1, which is the element at 0 in this case, is set to the key, which is 3. So effectively the number 3 was inserted before the number 4. So now this here is our current array list. And then in the next iteration, I is equal to 2. We set the key to be the element at I, which is 1. And j is set to I minus 1, which is the index of the previous element in the array list. And then j is greater than or equal to 0, and the element at j is greater than the key. So therefore the element at j plus 1, which is 1, is set to the element at j. And j is decremented, so j is equal to 0 now. And then j is greater than or equal to 0, and the element at j is greater than the key. So therefore the element at j plus 1 is set to the element at j. And then j is decremented again, so it's now equal to -1. So now j is not greater than or equal to 0, so the loop terminates. And then the element at j plus 1 is set to the key, which is 1. So as we can see, 1 was inserted before 3 and 4 in this array list. So our current array list looks like this. And now in the next iteration, I is equal to 3, and we set the key equal to the number at this index, which is 2. And then j is equal to the index of the previous element. And then j is greater than or equal to 0, and the element at index j is greater than the key. So we set the element at j plus 1 to be the element at j. And j gets decremented, and j is greater than or equal to 0, and the element at index j is again greater than the key. So we set the element at j plus 1 to be equal to the element at j. And then again j is decremented, and j is greater than or equal to 0, and the element at j is not greater than the key in this case. So therefore the loop terminates, and the element at index j plus 1 is set to the key, which is 2. So as we can see in this case, 2 was inserted between 1 and 3. So this here is our array list so far. So in the next iteration, I is equal to 4. The key is set to the element at index I, which is 8, and the index j is set to the index of the previous element in the array list. And j is greater than or equal to 0, but the element at index j is not greater than the key, so this loop terminates. So finally, the element at index j plus 1, being 8, is set to the key, so it's set to itself. And then the outer for loop terminates, and that's our sorted array list. So now if we look at the code, you can easily translate the pseudocode into this Java code for our insertion sort method, which takes in an array list of numbers. So pause the video and compare this code to the pseudocode. And then up here, we'll first run this program with the unordered array list. And then if we call our insertion sort method on this array list of numbers, we can see that the array list is sorted.